Okay, so 7.5, applying the tangent ratio. Today's the first day of trig, and I want you to understand this is just a very basic of trig ideas. Trigonometry in general is the study of the relationships of sides and angles. This is new. Normally we've just done sides or just done angles. They don't intertwine until now. Trigonometric ratios is the ratio of lengths of two sides of a right triangle used to find the side or an acute angle. So what we're doing is putting two things together. If you look at my examples over here, you can't do these examples without trig. You're given an angle and you're given a side, and you can figure out another side using trig. That's not something you could do before you learned this today. And this is the important stuff with tangent. There's three ratios that we're going to learn. Today is tangent. Then we'll learn sine and cosine next time. So with tangent, this black formula is what I need you to know. The tangent of angle A is the opposite leg of the adjacent leg. This is a formula that you need to memorize. So the tangent of angle A, this is an angle, this is a side length, and this is a side length. So looking at angle A, the opposite leg is over here, the adjacent leg is here. This is the hypotenuse that is not a leg. You can also find the tangent of B by doing the opposite leg over the adjacent leg. You can do the tangent of A or B. You cannot do the tangent of a 90-degree angle. You can't do sine or cosine of a 90-degree angle. With trig, it has to be an acute angle. So again, you can do the tangent of A or the tangent of B. You can't do the tangent of C. So I have some examples here. So with this one, with all of them, you're going to be using tangent. That shouldn't be a surprise to you. I'm writing my formula first. I plugged in the tangent of 40. This is what I plugged in. A is 40 degrees. The opposite leg is x. The adjacent leg is 20. So I set up my equation. Tangent and 40 cannot be separated. You have to keep those together. So to solve this, to get x by itself, we multiply both sides by 20. So on my calculator, I'm doing 20 times the tangent of 40. So I have x equals 16.8. And at the very end of the video, I'll show you how to use your Desmos to do that. Example 2, very similar kind of problem. We're going to do the tangent of 58 equals opposite over adjacent. That's where this comes from. In order to solve this, because our x is in the denominator, we have to get that x out of the denominator. So I created a proportion by putting a 1 under the tangent of 58, and I did cross products. That's where this came from. So with my cross products, I need to get x by itself, so I divide both sides by the tangent of 58. And on my calculator, I did 33 divided by the tangent of 58. That gives me 20.6, and we'll always round to the 10th place. The orange one's a very similar setup than the last one. So we're doing the tangent of 20 degrees equals opposite leg over adjacent leg. So the tangent of 20 is 8 over x. I created cross products. And when I did cross products, we're going to divide both sides by the tangent of 20. And on my calculator, what I did was this. 8 divided by the tangent of 20, and that gives me 22 rounded. Finding the area, we don't know the height, so we're going to use our tangent ratio to find that height so that we can find the area of the triangle. We have to know the base and the height. So again, I use that same idea, tangent of 35, opposite over adjacent. And when I solved that, I got for a height of 9.8. Then I can plug it into my formula, 1/2 times the base times the height, and this is the area. Real quickly, I want to show you how to use your calculator on your screen. So on Desmos, up here in the corner, that little wrench, when you click on that little wrench, you need to scroll all the way down and make sure it's in degrees. If it's in radians, it will not be correct. When you put it in over here, I'm going to do one example for you. The last example was 8 divided by, under functions, the sine, cosine, tangent will pop up. The tangent of 20, this was example number 3. You can see that it comes up as 21.97, which rounds to 22. If you need more help with Desmos, just let me know.